Assalamualaikum and good afternoon to all of you. My name is Muhammad Asfar Al-Jay. Today I will do a presentation about higher order partial derivative. Okay, the question that I want to present is find del of 2f over del y del x for equation f xy equals 90 to xy. Okay, to find del of 2f over del y del x, we must find the first partial derivative and differentiate the equation with respect to f. Okay, step 1 is we differentiate del f over del x and let y as a constant. We rewrite the equation 9e to the power 2xy del over del x bracket 2xy, and then we get the answer. The answer we multiply 9e to xy bracket 2y del over del x bracket x, and the first order partial derivative answer is 18y to xy. Okay, and then we continue to solution number 2. Therefore, the second order derivative is del over the of 2f over del y del x, that equal to del over del y bracket 18y e the power 2xy. The answer is we get from the first partial derivative differentiate, and then the answer we use product rule formula. We let u equal to 18y, u prime du over del y equal to 18. Let v e to xy, v prime del v over del y equal to s e to xy. Okay, we substitute the equation based on the formula being used. Bracket e to x e the power 2 xy bracket 18 plus bracket 18y bracket 2 x e the power 2 xy, and then we get the answer. We simplify the answer, and the final answer for second order derivative is 18e to xy bracket 1 plus 2 xy. Okay, the experience that I get when doing this equation is we must list down the formula that we used for the question before we can process to the next stage. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good evening to everyone. My name is Muhammad Hakim bin Samsudin. Today I want to present about question related rates problem. So the question is the pressure P in kilopascal, volume V in liters, and temperature T in Kelvin of a mole of an ideal gas are related by the equation PV equal 8.31 T. So find the rate at which the volume is changing when the temperature is 350 Kelvin and increasing at a rate of 0.05 Kelvin per second, and the pressure is 70 and increasing at a rate of 0.02 kilopascal. So we write down all the information below. So we get the dV equal to 8.31 T, and T equal to 350 Kelvin, and dt over dt is equal to 0.05 Kelvin per second, and P is equal to 17, and dP over dt equal to 0.02 kilopascal. And then we rewrite the PV equation and make the V as the subject. So we got the V is equal to 8.31 T over P, and we find the first partial derivative, and the first partial derivative, the dV over dt is equal to 8.31 over P, and dV over dP is equal to negative 8.31 T over P squared. So after that, we draw the T diagram to construct the formula. So we write the formula dV over dt is equal to del V over del T minus multiply that dt over dt plus del V over del T multiple dP over dt. After that, we substitute all the information into the formula. So we got dP over dt equal to 8.31 over P bracket 0.05 bracket plus bracket negative 8.31 T over P squared bracket 0.02 bracket. After that, we substitute the value of P and T. So we got the dv over dt is equal to 8.31 over 17 bracket 0.05 bracket minus bracket 8.31 bracket 350 bracket over 17 squared bracket 0.02 bracket. So we got the final answer dv over dt is equal to negative 0.1567 liter per second. So the volume is decreasing at rate of 0.567 liter per second. And the experience that I get from this problem is we need to draw the T diagram to easily construct a formula of the chain rule. Thank you and good luck.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmed Aizat. Today I would like to present the question about applied change in engineering application. So the question is the power consumed by a resistor is given by the following relationship, which is P is equal to V squared over R. Which is the question is determine the approximate change in power when the voltage V changed by 3% and the resistor R decreased by 0.4%. The original value of V and R are 40 volt and 8 ohm respectively. So firstly we list down the information given in the question, which is delta V is equal to positive 3% V and delta R equal to negative 0.4% R, and V is equal to 40 volt and R is equal to 8 ohm. Okay, firstly we differentiate P with respect to V and R, which is firstly we differentiate P respect to V, which is the answer is 2V over R, and secondly is we differentiate P respect to R, which is negative V squared over R squared. So after that we use the formula given and fill in the information that we have, which is delta P approximately del P over del V times delta V plus del P over del R times delta R. We fill in the information. After that we get delta P approximately 6% V squared over R plus 0.4% V squared over R. After that we solve it and we get 6.4% P, which is P we get from V squared over R based on the formula. So the power is increased by 6.4%. So the tips or experience that I use in this question, we must list down every information given by the question so that we can determine the step to use to solve the question. Besides that, we can minimize the careless to solve the question. Okay, thank you and good luck.
Assalamualaikum warahmatullahi wabarakatuh and very good evening. I am Ahmad Ibn bin Ahmad Kabar and I want to present to you a question regarding optimization problem. The question is, a container with an open top is to have 10 meter cube capacity and be made of thin sheet metal. Calculate the dimension of the bulk if it is to use the minimum possible amount of metal. To minimum the amount of metal, we need to construct a function of total surface area. The formula for total surface area of an open top container is A is equal to top plus bottom plus left plus right plus front plus left. At this part, there will be the surface area for the bottom only because this is an open top container. So the A is equal to xy plus yz plus yz plus xz plus xz, and the A is equal to xy plus 2yz plus 2xz. From the question, we can get the value is equal to 10. Length times width times height is equal to xyz, and xyz is equal to 10. Then we write back this equation so that the z will be the subject. Z is equal to 10 over xy. And then we take this value of z, we substitute back into the equation 1, and then we can get A is equal to xy plus 20 over x plus 20 over y. And then we need to find the value of x and y, which will give the minimum total surface area. First, we need to find all the first partial derivative. By using this formula, we will get that del A over del x is equal to y minus 20 over x squared, and del A over del y is equal to x minus 20 over y squared. By letting these two equations equal to 0, we will write back the equation 1 and B the y as a subject, and we can get that y is equal to 20 over x squared. Then we will substitute this value of y into equation 2, and we can get that x minus 20 over x squared power of 2 equal to 0. Then we will expand this, and we can get that x minus 20 over 400 over x power of 4 equal to 0. And then we simplify that, and then we can get the x minus x power of 4 over 20 equal to 0. And then we will multiply all the part, the left part and the right part with 20, and we can get that 20x minus x power of 4 equal to 0. And then we can get that x equal to 0 and x equal to 2.7144. We cannot use this value of x because the x must be greater than 0. And at this time, we need to find the value of y and z. By using this equation, y equal to 20 over x squared, we will substitute the value of x that we find before into this equation, and we can get that y is equal to 2.7144. And then by using z is equal to 10 over xy, we will substitute all the value of xy, and we can get that z is equal to 1.357. Next, we need to use the second derivative test to determine whether x equal to 2.7144, y equal to 2.7144, z equal to 1.357 will give the minimum total amount of metals. We need to find all the second partial derivative. By using the first all partial derivative, we can get that del squared a over del x squared is equal to 40 over x cubed. Del squared a over del y squared is equal to 40 over y cubed. And del squared a over del x del y is equal to 1. This is the formula for second derivative test. And then we will substitute all the information that we get into this equation. And then we substitute the value of x and y at this equation. We can get that 3.00. This is greater than 0. Then we need to find del squared a over del x squared is equal to 40 over x cubed. Then we will substitute the value of x, and we will get that 2.00. That is greater than 0. The conclusion is that the container should have length 2.714 meter, width 2.714 meter, and height of 1.357 meter, so that it will give a minimum amount of metal. The new experience that I gained from this assignment is teamwork is a very important for group assignment. When you have a great teamwork, you will have a great result at the end. That's all from me. Thank you.